Now in this video, I'm going to explain you how you can find the derivative of inverse trigonometric functions. So first of all, these are some of the formulas which are actually very important while finding the derivative of inverse trigonometric functions, and you can memorize these. And if you want to really access these formulas, you can check out the PDF given in the description of this video. So it would be much helpful for you. And some of the guys asked me that how can we memorize these formulas. So I think personally the best way to memorize any formula given in math or physics is by solving more and more examples related to it. So in the upcoming videos, I think 10 or 9 videos, we are going to solve these questions which are related to inverse trigonometric functions. So you will get a lot of practice and you will have one-on-one experience with these formulas. So I hope that if you solve all of those 9 questions, you will memorize and these formulas will actually be fitted into your minds. Okay, so for now, with these formulas in mind, we have to find dy by dx of this function cos inverse x over a. So first of all, let's say that this function is actually equal to y, because the question is saying we have to find dy by dx. So we have to differentiate y with respect to x. Okay, so then let's just apply the differentials on both sides of the equation. D by dx cos inverse x over a. Now we have cos inverse x over a, which is actually equal to -1 divided by the root of 1 minus x squared, right? Over here we have cos inverse x over a instead of x. So wherever we are having x, we are going to replace it with x over a. So we can simply write -1 divided by the square root of 1 minus, instead of x, we are going to write x over a, because now that's the term which is present with the cos inverse. Okay, so we have x over a squared. -1 divided, now we can just simply simplify these expressions. -1 divided by x squared divided by a squared. This thing is actually present under the root. Okay, so -1 divided by the root of, we are going to take the LCM, so a square would be my LCM, then a square multiplied by 1 is a square minus the x square, because it is the denominator of x squared. Okay, so then we have -1 divided by, so this a square will be cancelled by the square root, and this a square minus x square remains, so we have a square minus x square divided by a. Okay, so now this a which just came out of the square root is actually the denominator of the denominator, right? It is something like a over x over n, right? And when we have such a situation, we can move this n towards the numerator, so it can be written as a multiplied by n divided by x. This is a basic rule which we have been studying since I think 9th grade. So this can be written as -1 multiplied by a divided by a square minus x square. And so this is the final derivative of the function cos inverse x over a. Okay, let's try one more of these. Now the question is saying that you have to find the derivative of cot inverse x over a. So first of all, let's make this equation a function. So y is equal to cot inverse x over a. Then we can simply apply the differentials on both sides of the equation. So we have d by dx cot inverse x over a. Okay, so from the formula sheet, we know that the derivative of cot inverse x is actually -1 divided by 1 plus x squared, right? But the angle which we are having for this general formula is actually x, so we are putting in x. But over here in our question, we have the value of this thing as x over a, right? We cannot call it as an angle because it is not the angle. If we just, as a side thing, if I just tell you, if you are considering cot theta is equal to some value, then theta is actually the angle. Now if I'm taking the inverse of this thing, it would be cot inverse, the value would be equal to theta. So I cannot call this thing as an angle, so let's just say it is a value, it is a number or whatever. Now we have x over a, so we can simply write 1 divided by 1 plus, instead of writing x, we are going to write x over a. Okay, so square, and then we have to simply simplify this equation. 1 plus x squared divided by a square, then -1 divided by, we have to take the LCM, a square plus x square, then we have -1. The a square will be again in the numerator, so we have multiplied by a square divided by a square plus x square, and then we have -a square plus a square plus x square. So this is the final derivative of cot inverse x over a.